Hello, and welcome to Becca Breaks It Down. In today's episode, we are going to explore the long-run behavior of polynomial functions with a focus on polynomial functions in standard form. So a polynomial function is the sum of power functions with non-negative integer exponents. So when they say non-negative integer, they mean like 0, 1, 2, 3, 4, 5, and so on. Okay. We can write a polynomial function in standard form. And so like this is kind of like representing what standard form would look like. Notice there are no parentheses with factors or anything like that. It's just expanded. Okay. The leading term is the term that has the largest degree. So we're talking the largest exponent. Okay. We call the coefficient of that leading term the leading coefficient. And then the constant coefficient term is the initial value of the function. So plug in 0 for x, calculate, we're talking that value. So it's the y-intercept of the function. Now I had you explore polynomial function graphs before this episode here, and I presented you with these 5 graphs, and I said, what do you notice about the degree and the end behavior? And these are the kind of things that you guys said. The end behavior is the same for all odds and then the same for all evens. So like our odd functions would be the 1, 3, and 5. Okay, and then evens, of course, 2 and 4. Even numbers have end behaviors that are going up or going the same way, and odds have their end behaviors going in opposite directions. So odds are going in opposite directions. Evens are going the same way. Each even degree has both ends pointing up on the graph, whereas the negative number degree has one arrow up, one negative down. So I think what was meant here was odd degree has one up, one down. Odds end up in different directions and evens end up in the same directions. So those are just 4 of your responses, because basically you were all noticing the same thing when it comes to end behavior and the degree of the polynomial function. So basically, even functions have equal end behavior and odd functions have opposite end behavior. So we use something called the leading term test when it comes to end behavior. By the way, end behavior is the same thing as long run behavior. Just be aware of that. It's just a matter of terminology. So when it comes to end behavior, it's all based on the leading term. So remember, the leading term is the term that has the largest degree in the polynomial. Okay, so we want to look at that leading term and we want to ask ourselves like 2 questions. That leading term, is it an odd degree or is it an even degree? And then, is it positive or negative? Because like all odd positive polynomials will have an end behavior that on the left goes to negative infinity and on the right goes to positive infinity. All odd negatives will have an end behavior that on the left goes to positive infinity and on the right goes to negative infinity. So you guys realize that odd degrees have opposite end behaviors. Going back to these graphs that I gave you guys, all 3 odd degree functions, the linear, the cubic, and the quintic, since they're all going down on the left side forever and up on the right side forever, we would say these are odd and positive because they're following the rules for an odd positive degree polynomial. Even degree polynomials, you noted, have even end behavior. So if it's even and positive, then it's going to be positive infinity for both ends. And if it's even and negative, it's going to be negative infinity on both ends. So it all comes down to the leading term. okay? The term that has the biggest exponent, it dominates the function and it determines the end behavior. So let's take a look at these examples here. So in number 1, we have the polynomial function x cubed plus 3x squared minus x minus 3. So we want to be like, well, what's the leading term? And that's the term with the biggest exponent. So our leading term is x cubed, okay? Now I would describe x cubed as being odd in terms of degree and being positive, like the term itself is positive. And so when we're odd and positive, then on the left, we have an end behavior of negative infinity. And on the right, we have an end behavior of positive infinity. In problem number 2, the term with the biggest degree would be x to the 4th. It's a 4th degree polynomial, ergo that's an even. And furthermore, x to the 4th is positive, so even positive. So even positive functions have equal end behavior, and on both sides, it's positive infinity, right? So these two problems focused on end behavior of a polynomial function given to us in standard expanded form, okay? So the leading term test, remember, is the term that has the biggest degree, okay? So like looking at this function here, it has an odd degree and the term itself is positive. So its end behavior on the left is negative infinity and on the right is positive infinity. This right here, I would describe that as being even, and it's also negative. So the left and right end behavior, both of which are negative infinity. And that's how Bakker breaks it down.